Hi, in this session we are going to talk about another question of recursion. So this question will give you a very clear understanding of recursion, and this is, I'll say, one of the medium level question of recursion, which means that if you're trying to solve this problem, you should have done some problems of recursion from beforehand that will help you in solving this problem. Okay, so let's just go ahead and let's do the drill like we do in all the question. First, we'll try to understand the problem statement. So the problem statement, I'll say it's pretty much simple here. It's straightforward. And then we'll try and come up with the logic. And then we'll see how do we come with the recurrence relation and how do we write the recursive code. Okay. So let's just first try and understand the problem statement. So as the problem statement says, Arnab is given a number n. You have to help Arnab print all binary numbers of length n with no consecutive one in lexicographical order. Okay, so here it's pretty simple. You're given a number n. You have to print all binary numbers of length n. When we say binary, which means that the number should have either 0 or 1, whatever thing I'm doing. And the condition is there should be no consecutive one, and we have to print it in lexicographical order, which means the smallest one should come first. Okay, so let's just see example what it is saying. So in this case, this is, I'm assuming, the number of test cases. 3 is n. So for 3 we have 0 0 0. So as you can see, this is of length n and only we have zeros. There is no 1 in this case, so this is binary. This is, again, we are having 0 and 1 and it is of length 3 again. This is 0 1 0, same binary, 1 0 0 1 0 1. So all I need is that I have to print all the pattern. The pattern should have only 0 or 1, and there should be no two ones together, which means if I try and print 1 1 0, this should not be the case. I can't print this. It could be either of these, right? So this is what we have to keep in mind. So that is the problem statement. So let's say if our n is equal to 2, or let's say if our n is equal to 4, what are the options we have? We can have 1 0 0 0 0 0. 4 times 0, we could have 0 0 0 1. We could have 1 0 1 0. 0 1 0 1. So basically, one thing I would like to tell you is that here we have just, there are various ways possible, right? There are various patterns possible, and that is why it's written over here that you have to print it in lexicographical order, which means in this case 4 times 0 should have come beforehand, and then any other number should have come, like 0 0 1. This is something we have to keep in mind, and there are many such patterns possible for n is equal to 4, in which there should be no 1 and 0, there should be no 2 1 consecutives. Okay, so this is what we have to do. I hope this problem statement is clear to you. Let's just go ahead, read the input output format, constants, and then we'll try and solve the question. Okay, so the input format is, first line contains integer t denoting number of test case, which is this. For each test case, an integer value n. So if the test case would have been like 2 test cases, then we would have like 2 different n's. If 3 would have been there, this would have been the output for 3. If 1 would have been there, for 1 we have 2 output, 0 and 1. For 2 we have 0 0 1 0 0 1. Okay, do I have anything else? No, I don't have any other output possible. Okay, so this is the number of test cases. These are n's, and for each test case, print all the possible numbers in a new line. So these are the possible numbers that we have to print. Constants, t should be less than equal to 5, t should be in range 1 to 5, n should be in range 1 to 7. Now let's just go ahead and try and solve this particular problem. Make sure the problem statement is really clear to you. If it is not, make sure you read it again, read it on your own, and if you have any doubt, just see what is the doubt. Since problem statement is pretty much straightforward, we'll just move ahead to the logic. So we have understood the problem statement. We will be given n, and we just have to print all the binary numbers of length n, and we have to ensure that no 2 consecutive ones are there. So let's say if my n is equal to 3, we have to print 0 0 0. What are the options we have? We have 0 0 1, 0 1 0, 0. Okay, that's it. We have 1 0 1, and we will have, okay, we'll have 1 0 0 and we'll have 1 0 1. So these are the options that I have. So what happens many a times is that for us to be able to solve a problem, Sometimes we get that, okay, this is a mathematical problem, or this is a puzzle, this is how I'm going to do it. Sometimes we just try and solve more and more test cases, and while we are solving the test cases, we just have to see what are the operations that we are performing. Okay, so let's say if n is equal to 3, we just did this particular thing. Okay, so let's say if n is equal to 4, what are the options we have? Number 1 is 0 0 0 0. Number 2 is 0 0 0 1 0 0 1 0. I'm not specifically putting in lexicographic order, okay? And other we have 0 1 0 0 0 1 0 1 1 0 1 0 1 0 0 0. I'm not necessarily putting in lexicographic order, I'm just generating all the cases, okay? Then we have 1 0 0 1 1 0 0 0. So while I am solving this, I just realized that every time I'm trying to make a new pattern, every time. So let's say if n is equal to 4, let's just see what we are trying to do. So we have, let's say, 4 places, okay? So what I'm trying to do is, I am putting, for every place, I have 2 options. I either put 0 or I put 1, okay? Now I started with putting this place as 0. Right? And for every other place, I have 2 options. I either put 0 or 1. So this is what I did, when here at this particular point, I started with 1, okay? And then I put 0 here. So for first place, I have 2 options. I either put 0 or I put 1, okay? Now at this place, again I have 2 options. I either put 0 or I put 1. But when I have already 1 here, and we know that we cannot have 2 consecutive ones, I have just one option here, that I put 0. Okay? And now again I see that if I put 0 here, I have 2 options here, 0 or 1. So let's say I put 0 here. In that case, again I have 2 options here, 0 or 1. So let's say I again put 0 here. Let's say, let's try another case. So let's say if there are 4 places again, I put 1 here. I cannot put 1 here, I have to put 0. Here again I have 2 options, 1 or 0. Let's say I put 1 here, here I have just 2 options. So as you can see that for every place, I just saw a kind of generalization, that for every place I have 2 options, 0 or 1. Now whether I have to put 0 or 1 will depend upon one more factor, that if previous place has 1, then I have no option but to place 0 only. And if previous place has 0, then I have 2 options. I put 0 or 1. So for every place, what we have to do is, we have to keep on filling the places one by one. And when I'm filling the place, I'll check that if previous is 0, I'll simply put 0 or 1 depending upon whatever I'm choosing to do. And if previous is 1, then I have no option but to choose 0, okay? Let's now try and be more clear with what I'm saying. Let's try and form a recursion tree. That will make things even more clear for us. Let's try and do that. So now we'll try and form a recursion tree. So now what we're trying to do is, whatever logic I have in mind, I've kind of generalized it. I just want to come out with a recurrence relation, okay? And I'm thinking that maybe making a recursion tree will help me around, okay? So that's why I'm just making a recursion tree. So let's say for first place, I have 2 options. I either put 0 or I put 1. If I put 0, again I have 2 options. I again put 0 or I put 1. If I have, let's say I'm taking n is equal to 3, okay? If I have 0 here, again I have 2 options. I either put 0 again or I put 1. Okay, so these are 2 end strings that I have. These are 2 strings I have. Now here we have 0, 1. For the third place, we have only one option. I put 0, 1, 0. Okay. Now again, let's say I start with 1. I have one option only, 0 for this place. Then again, let's say I have 0 here. So again, I have 2 options. I either put 0, that will give me 1, 0, 0, or I put 1, that will give me 1, 0, 1. So as you can see that I have got my digits. So we have, this is 1, this is 1, this is 1, this is 1, this is 1. So I got my 5 numbers, 5 binary numbers that have the following pattern, and they are also in lexicographic order. So I see that in order to print things in lexicographic order, I always have to give 0 the priority. Okay, so now this is the recursion tree. Let's just try and form the recurrence relation. So as you can see that I started with putting first place as 0 and 1. So let's do that. So let's say I keep an array. Let's say arrays of length n. I'll just initialize a of 0 as 1. Okay, I'll initialize a of 0 as 1. We have a of I will have the value 0 if a of I minus 1 is equal to 1, or a of y will have value 0 or 1 if a of I minus 1 is equal to 0. Okay, I will have value from 1 to n minus 1. The length is going to be n, and since we are starting from 0, so it's going to be 0 to n minus 1. Okay, so now we know that what we have to do. Let's just try and write the recursive code. And if the recursive code is not directly coming into your mind, let's just write the steps. Let's just try and write a kind of pseudocode, or let's just try and write the relation. Okay, so as you can see, in the very first we did that we initialized a of 0 as 0. Okay, so if I initialize a of 0 as 0, then for I equal to 1 to n minus 1, for every a of I have two options. I'll put a of I is equal to 0 if a of I minus 1 is equivalent to 1, or I'll put a of I equal to 0 or 1 if a of I minus 1 is equal to 0. Okay, similarly, this is one thing that we are going to do. This will help me create this whole complete branch. Okay, now for this branch we will do a of 0 is equal to 1, and similar thing for I equal to 1 to n minus 1, I'll have a of I is equal to 0 if a of I minus 1 is equal to 1, else it will going to be 0 or 1, or you can say and 1 as well if a of I minus 1 is 0. Let's just try and form a code out of this. Okay, so let's say the method is binary. Okay, so we have to decide on what are going to be the parameters, how the parameters are going to change. Okay, and we also have to decide what is going to be the base condition, and how is the recursion going to happen, or how the recursive call is going to happen. So one thing I know for sure is one parameter is going to be k. Basically, k is going to take care of the place we are filling in. Okay, so in this case initially we'll start with this one, this one. So basically whichever place we are deciding that whether it will be 0 or 1, that is going to be k. Okay, so let's just decide on. Okay, so we have seen till now how are we going to solve the problem. Let's just try and write the code. So we know that in case of recursion there are several things that we have to see. Number one, we saw that we have to decide what are the operations that we are going to perform. Then what are going to be the parameters. And then also we have to see what is going to be the written statement or written type, let's say, and what is going to be the base condition. Okay, so before I just go ahead and start writing the code, maybe I'll have some sort of steps written in front of me that will help me in writing the code. So I'll start with initializing a of 0 as 0, and then I'll initialize a of 0 as 1. I'll do this one by one. For a of 0, first what I'll do is I'll call this method. Let's say the method is binary. Okay, I'll call the method binary with the parameters. In this method binary, what I'll do is I'll check if a of I minus 1 is equal to 0, then I'll simply do a of I is equal to 0, and I'll call binary again. And then what I'll do is I'll do a of I is equal to 1, because I have to check both the methods, right? Because I have to put both 0 and 1 at that particular place, right? And then I'll call the binary again. Okay, and if we have a of I minus 1 not equal to 0, then I have only one option. I'll put a of I is equal to 1, and I'll call the binary method. So I have a kind of thing clear in my mind that how I'm going to write the code. Let's just try and write it. So we will have the main method. So let me put it here. We will have the main method. Let's say we have n. we'll have an array, let's say it's an int, okay, an array of size n, okay, and then let's say whatsoever be the n, I'll just initialize a of 0 as 1. Sorry, we have to do it in lexicographic order, so every time we'll first do the 0 thing, okay, and then I'll call this binary method. So one thing I know for sure is that I have to pass this n as the parameter, and also I have to pass this I as the parameter, okay, so let's just keep it k. Okay, and another thing that we have to do is we have to pass this a as the parameter. It would have been better if we would have done it in reverse way. Anyways, so I do this. Let's just try and write this binary method. So in this binary, I have int n, I have k, and I have the array. We have taken the integer array. Okay, so now the thing is, what is going to be the base condition? So we have seen while we're making the tree that we are trying to fill these positions, and the moment we fill all the positions, we know we have to print. So the moment we get k is equal to n, we simply print the array, let's say print the array, and I'll return. Okay, this is what I'm supposed to do. Okay, now what are the other operations that I have to perform? I check that if a of k minus 1 is not equal to 1, okay, in that case I'll just do a of k is equal to 0, and I'll call binary. I'll keep my n as it is, I'll increment my k, and my a remains as it is. Okay, and then I again put a of k is equal to 1, and I have again binary n comma k plus 1 comma a. Okay, and write it here. Now this was my if. The else is going to be a of k is equal to 0, binary n comma k plus 1 comma a. Okay, so that is going to be my code. So now you must be wondering that how do I know that there's going to be this binary, then this binary? How do I know I have to print here? How do I know what is going to happen if I return? So as I said, that for you to be able to solve this problem, you should have already solved some problems of recursion from beforehand. So this is how things are. For us to be able to solve some problem, we need to have some sort of practice from beforehand if the problem is of certain level. So that's why with the practice that I have had, or anyone who is solving this problem, and as you can see, this is question number 7 in recursion, which means that if you are solving this question at PrepBy's website, there are 6 questions that you have already done. There are some videos that you have already seen if you're in the course. So that will clear your mind, and that will make you ready to come at a place where you can think like this and write this particular code. Okay, now I have the kind of logic in so I have written the code. Let's just try and write the code in language, and let's just try and write the production level code such that if I write the code should compile successfully. And let's see that whatever we have written, this is kind of we have written with whatever idea we have we have written with idea what we had in our mind. Let's just see that if this code works fine or not. So let's just go ahead and write the code in the compiler. Before that, we missed one thing, that we initialize a of 0 as 0. The same thing we have to do for 1. We have to initialize with 1, and then we have to just go ahead with binary n comma, this is going to be 1 actually, n comma 1 comma a. This is how the main is going to look like. So let's just go ahead and try and write the code. Okay, you must have thought initially that what is it this k is going to be. It is going to be 1. Okay, so we have seen the logic till now, understood the question, tried to implement the code. Now we will just go ahead and write the code in Java language, because obviously that's necessary for our code to run somewhere. Okay, so we'll just write it in Java language. One thing I would like to tell you is that in case you haven't come up with the code on your own, in that case definitely you have to run this code. You have to write this code on your own after the video and run it. Plus you have to dry run the code, because it is really necessary that you see how recursive calls are happening and how things are going ahead, because if you don't understand that, it will be difficult for you to solve the next problem as well. So for you to be able to solve the next problem on your own, it's really necessary that you dry run the code. Okay, so let's first see the code. We'll write down the code and then we'll just go ahead and dry run it. Okay, let's just do that. So we have already taken t as input. We are running the loop t times, and we have taken n as input and have created an array a. Okay, now let's just go ahead. So what we decided was that we'll fill the position 0 with 0, and then we'll just call the function. So here the function is print binary. I have already kind of written the skeleton. We have print binary. So here we have a as a, k is going to be 1 and n is as it is. Okay, this is one thing, and then we decided that we'll first put 0 and then we'll put 1. So we put 1 and then again we call the same method. Okay, so in some case I might be calling function or method. So since I code in all the languages, I sometimes get excused. So if I'm saying function, it's method. Okay, in case of Java it's method. So let's just do that. Okay, so we have print binary. Now let's just go ahead and write the print binary method. Okay, so I'll just start with writing the base condition since I already know that. So the base condition is going to be if k is equal to n, which means that I have already formed a binary number. And here, you know, I'm taking the things really basic. I've taken an integer array, but you can do the same thing using strings as well. But since I have started the whole thing with integer number and binary number, so I'll just go ahead with the integer as well. But you can take strings as well, or you can take character array depending upon what you want. Okay, so let's just go ahead. So here we have if k is equal to n, I'll just print the array elements in a very basic format. We'll just go ahead with int I is equal to 0, r less than n, r plus plus. So we have just printed all the numbers. We haven't had any new line because that has to be a number has to print it together. And after we have printed one number, we have a new line. Okay, because different numbers have to be printed in new lines. Okay, so once we have done that, what we need to do is we need to just return from here. Then we have to check that if a of k minus 1 is equal to 0, which means for kth position I have two options. A of k is equal to 0, and then I call the same method. So basically here I am putting a of k as 0. I'm just concentrating on the current position. I put a of k of 0 and then I call print binary method again to decide that what are going to be the next positions, what's going to be the value for the next positions. Okay, now another option that I have is I put a of k is equal to 1 and I again call print binary. And if a of k minus 1 is not equal to 0, which means it is 1, in that case I have just one option that I put a of k as 0 and I call this. Okay, so as you can see, I'm doing lots of copy paste here. So yeah, so this is how my code is. Let's just see if the code runs fine. Okay, so let's just put 3 as number of test cases. Okay, I got an exception. Let's see what is the exception. Okay, I'm getting stack overflow error. Why is that? Example of print binary a comma. Okay, so as you can see, you know, I just got an exception because why? Because I am not changing the value of 1 here. So I'll just change the value of 1. Sorry, I'm just changing the value of k. So this was a kind of case of infinite recursion that happened, as a result of which we got stack overflow. So you got to know about this error as well through the video. Great. So let's just run this again. Okay, I have to put k plus 1 here as well. Cool. Let's just run this again. Okay, we have 3. We have 3. So let's just see if this is the right output for 3. Yeah, it is. Let's just put another input. We have 2. Okay, let's put 1. Okay, so we have given very basic inputs. I'll just try and submit it. If I get right answer, cool. But if I don't get the right answer, probably I will check for more test cases. I'll change this to main. Okay, I got my answer accepted. So we have got our answer accepted. Make sure you're trying this as well. And then we'll just go ahead and dry run the code to understand. I'll just take maybe k equal to 3 as input and then see how the binary numbers are getting formed. Okay.